sort of welcoming everyone to the International Day of Mathematics, which should actually have been celebrated on the 14th of March. But obviously, because of the work schedule and so many reasons, we couldn't. So we are doing it retrospectively. And so using the opportunity to sort of welcome, and I do recognize all of our speakers. Informally, we'll try to test our audio here and there just to ensure that folks can hear us. And I'm also welcoming other colleagues who are not speaking, but just being part of the conversation. I call it conversation because it's actually pure conversation and discussion from this month onwards right through the end of the year, if we happen to have such sort of conversations. Now, I also would like to bring this to light that this will be the first of its kind as we look forward to monthly webinars or seminars specifically for mathematics and STEM in general. And for that reason, I'm using that opportunity to sort of throw that picture out there for you to know that if there's time and space monthly towards the end of each month, we would be hosting something like this. And there are several reasons for that. In fact, one of the reasons is primarily based on some of the points our speakers will be highlighting under 10 minutes. So I wouldn't want to steal their time by speaking a lot as to why we need to be doing this from time to time. However, the second reason is also tied closely to the motives or the objectives of International Day of Mathematics, which is actually spearheaded by the International Mathematical Union. I will speak to that in a second or a minute. I think one of the things I need to touch base on is the fact that it isn't like our seminars or webinars, future webinars would be celebrating these kinds of international days. But as a faculty looking into issues of mathematics, as a university looking into issues of mathematics, that is pure maths, applied maths, educational mathematics education, we thought something like this would be nice for us to bring together practitioners gradually. I know this is the first time, so the numbers might not be as we so wish, but in future as we grow, this would be substantial. Primarily or historically, I would say the International Day of Mathematics seems to have been denoted as a Pi Day, and obviously the reason has been traditionally because of the date being written as the 14th of the third month, and which is why it is often written as 3.14 as the Pi Day. And so in some countries, they actually observe it as the Pi Day. And so if you ever hear of the Pi Day, it's actually almost synonymous to the International Day of Mathematics. And in future, if there's a need, we would celebrate something similar. But for the most part, we would rather be looking at issues in STEM applications of mathematics, not just mathematics itself, but how we apply it in business, accounting, how we apply it to improve our social life, AI. It cuts across faculties and departments. And for that reason, we should possibly look forward to something like that from time to time. And I just in a second indicated that the International Day of Mathematics is actually led by the International Mathematical Union, which for the most part is also a worldwide initiative. Both are international non-governmental and both are also non-profit scientific organizations. In future, those of us who tend to get ourselves associated with these organizations or these international initiatives could further, as it were, get in touch with them, which is why I've shared the screen with you. You would have lots of resources beyond what our colleagues will be talking about, and even me sort of highlighting. And I guess the key or the motive for these two organizations, the parent organization, and I would say the subsidiary, and for the most part, even within South Africa, our own maths-related organizations, if you are associated with one, SAMSTI and others, we all have almost invariably the same motives, or I would say invariably the same objectives. Essentially, what we try to do is to highlight, connect with some mathematics and mathematics ideas, concepts, the field of mathematics. We link it with, as it were, international activities. And so the first objective, not just of IDM, not just of the International Mathematical Union, but even this particular seminar and moving forward beyond today is to sort of promote both local and international cooperation if we can. This is not primarily the objective of this particular seminar, but it ties closely with this seminar, and hence we're using that as a springboard for that kind of cooperation, that kind of support. The second objective is also to support and assist both local and international Congress of Mathematicians. In South Africa, we also have, I'll call it derivatives of such associations. And so it's possible that we also work within this field, but I'm using this as a springboard for us to familiarize ourselves with some of these objectives that we tend to get ourselves linked with. And we also, one of the key objectives is also to encourage and support international mathematical activities. And these forms of activities, these activities tend to range from the sort of the mathematical sciences right through to the pure applied maths. Of course, we have our head of department from the maths department also being one of the speakers. Was just sensible to have him here to give us a talk on some of the things they're doing. And Faculty of Education being the faculty hosting it, of course, you will see that one of the things, one of the objectives is to sort of encourage those educational activities beyond just talking about it in class, beyond just talking about it on the street. But we see how we can coordinate those collaborations. So you see this kind of activities spread across. I've deliberately used pictures to exemplify what I want to say, because as we know, the cliche, the pictures tend to speak louder than words. You notice that, I mean, it's not just because I'm in maths and possibly our students, you find it across all kinds of disciplines, be it business. I mean, this graph tells you a little bit about sales and original price. So you're basically talking of some finance, some economics, some accounting, and so on and so forth. You find it in health science, you find it in chemistry. I mean, a host of other fields. So AI, for instance. So, well, there's a good reason why we probably have to continue with this initiative gradually, hoping that as we move on in the course of time, we build up that rapport and bring together our pre-service teachers, in-service teachers. Fortunately, we have our own head of department here who would be talking to a slide or two regarding something of the nature we're doing in PGCE, some of the good things that we're doing. I think informed by this, I guess it's important we continuously work together with not just Faculty of Education, but of course, what would I say, other faculties. Hence, we have our head of department from Maths also here coming to talk to us. So I guess to sum up, what I hope we hope to achieve is go beyond just being a talk show, go beyond just simply being a faculty of education, but see it as something we would continuously pursue in variety of, in different forms. And of course, another point we need to understand, which I won't speak much on because we have a colleague who will be talking about that, is the team. The team for this year's IDM is Mathematics Unite, and I think it's self-explanatory because of the common language of mathematics, seven other disciplines. You know, it cuts across AI, it cuts across business, health sciences, it tends to cut across many other fields. And so this year, folks dubbed as it were, the team as Mathematics Unite, but I would also wouldn't want to steal the shine here. We have someone who will be speaking a little bit into that. And it's actually based on those objectives and the synopsis that I've just provided that we call upon a number of our colleagues to share their views with us. We have a conversation around this. And we'll also look forward to the future, seminars, webinars, particularly talking about issues, teaching-related issues, learning-related issues, applied-related issues of mathematics. And in future, we don't also mind to have you, share your ideas with us regarding your own experiences. I know the configuration here is not just staff members, we have students. In fact, that's the reason why we have even students actually being part of the talk. In future, we don't mind having you as the key speakers. You share your own experiences with us regarding how we can improve the uptake when it comes to mathematics, improve the uptake when it comes to STEM. Well, with this, colleagues, I would love to stop. Welcome you guys all to the monthly webinars. This is just a start. And also welcome our speakers. Welcome our colleagues who would be contributing to whatever we discuss here. In fact, that would be the part that I'm playing here, just painting a picture here and hoping to interact with you afterwards, after each session or after the entire session. I use the opportunity to welcome you formally. Thank you very much. And so we would be moving on to our first speaker, possibly to share their views with us. Thank you. That's all I have for you this morning. I'm not sure if someone wants to say something before we move on to the first speaker. You are allowed to say something before we move on to the first speaker. Right, I'm done.
Thank you, Prof. Bayaga and colleagues.
Oh, yes,
and students. I just want to say, this is a wonderful initiative, Prof. Bayaga, that you are driving. From your introduction alone, just explaining what pi is, and the 3.14 and how we got to the date of the 14th of the 3rd was interesting. I'm sure those in this meeting will also find it fascinating to learn about these things. So from my side, Prof. Bayaga, I just want to thank you for taking this initiative and driving this initiative. And initially I thought this was going to be a once-off event. And I'm happy to hear that you're thinking of doing it on a regular basis. The whole idea is, of course, to increase awareness and increase interest in mathematics. And so I applaud you for taking this initiative, and I wish our presenters and our speakers today all the very best. Thank you, Prof.
Okay, all right. Look, I think let me go one step backward. Actually, I think because I was also presenting, I didn't see our Deputy Dean. So one of those, I would have also acknowledged his presence. Of course, our Deputy Dean has been quite instrumental in this up to this point. And so from time to time, you would hear our Deputy Dean speak a bit in terms of what we do. in future, don't be surprised that he's also actually the key note speakers here. So welcome, Deputy Dean, and we really appreciate that you are part of this first session. Hoping to see you from time to time in the coming sessions. So that's it. And of course, I use the opportunity to also welcome Ms. Karen, that is representing the JMMDC, the Government Banking Center. We do recognize your presence and many of the colleagues from the Government Banking Center, and also our external colleagues. Otherwise, for my part, I'm good. There isn't much to say. I'll hand over to our dear Miss Amy and Mr. Blana to speak to share the ideas with us. Thank you, colleagues. Yeah, you can move on, Miss Amy and Blana.
Many thanks, sir. Good morning, everyone, once again. My name is Amy Lee Sanson. Just wanting to start off by asking you to please excuse me for sounding a bit nasally this morning. I am trying to fight off a cold. But yeah, if I jump right into it, I'm going to start sharing my screen. If a few people can just indicate that it is being shared. There we go. Ladies and gents, can you see the first slide on the screen? The title is International Day of Mathematics.
Yes.
Perfect. Thank you, Prof. Early in the month of Letlo Honolo Bulana and I had the opportunity of designing and creating an infographic on the International Day of Mathematics under the guidance of Prof. Biyaga. The instruction of this new assignment did not at first excite us, particularly due to a very busy fourth year B.Ed, SP and FET program. But after researching what the IDM is, discovering what their objectives are, and unpacking facts about the importance of mathematics, our perspective changed. Today, Mr. Bulana and I have been tasked with presenting on the theme for IDM 2022. Through this presentation, we wish to introduce this year's theme, inform you on how the IDM is celebrated, highlight 3 themed galleries for this year's photo challenge, and lastly, discover a fraction of the 3,200 odd images sent in showcasing the many ways in which people from all over the world understand and experience mathematics in their daily life. The theme for IDM is universal, and this is very apt, seeing as though mathematics is the universal language. The cultural and linguistic diversity, differences between people based on social indicators, and the myriad of challenges that we face as individuals or communities do not have any place in the IDM. People with which we would not usually interact with come together, having maths as a common subject for celebration. And Yulia Nestorova, a graduate student from the University of Ottawa, Canada, proposed the theme for the 2022 International Day of Mathematics, and that is Mathematics Unites, as Prof. vaguely mentioned in his introduction. She supported the theme by saying, and I quote, "Mathematics unites to signal that it is a common language we all have and a common subject with which to find one another." In light of the COVID-19 pandemic, Mathematics for a Better World was chosen as the theme for 2022, last year's International Day of Mathematics. The theme chosen for the first IDM, which was held in 2020, was Mathematics Everywhere. But it seems as though 2022's IDM quantified the greatest number of events organized by people or organizations in cities worldwide with over 1,961 accounts of its celebration, which I think is fantastic. The IDM is celebrated in two ways. Firstly, there is a global online celebration where short talks are given by guest speakers in 5 different languages, these being English, French, Spanish, Arabic, and Portuguese. It is also celebrated by an individual or team photo challenge where entrants must take a picture with mathematics and share their ideas. For the global online celebration, topics that are discussed include the importance of mathematics and how mathematics unites us. Streaming sites are free and no sign up is required, making it accessible to all. And this just reiterates the international celebration and how there are no limits to the people who are involved in the celebration. With regards to the photo challenge, mathematics is more than numbers, so people were encouraged to consider geometric shapes, patterns and sequences, and formulas, amongst many other things. What could be used for a photo challenge? They encouraged people to use mathematical objects that they could build, draw, or form. A mathematical building, bridge, or statue from your city could have also been used. And then they went further to ask people to discover math that may be hidden and reveal it in certain ways. I now hand over to Mr. Bulana, who is going to help us discover some images that were sent in for this year's photo challenge. We will explore 3 themed galleries. Firstly, United by Mathematics. Secondly, some mathematical landscapes. And thirdly, where can we see mathematics? The answer to that is everywhere. And then I've also pasted a link to the IDM website where many more photos that have been uploaded can be viewed. Hloni, you can come in.
Good morning, colleagues and all our guests who are here today. So my duty is to speak about the themes that were discovered or came about from the photo challenge, as Amy has highlighted. The ones would be united by mathematics, the landscapes we see, and maths that we see around us. Amy, if I could ask you can just go to the next slide for us. So in this first picture we see where we are depicting the unity, where we'll find a picture that is found from India. And what we can see inside this picture is a Fibonacci spiral formation. And this is quite a unique structure or formation where there's a golden ratio of about 1.618, and simply means that numbers exceed each other by this specific golden ratio. And a real life application would be the formation that has been created by our colleagues in India. And also another application or real life application of this Fibonacci spiral formation would be in our DNA for those of us who are in the life sciences field. Thank you, Amy. And then a unique picture that we see today is the picture of pi. Prof. Bayaga spoke a lot about this, and this is an image that was created by participants from Italy. And as you can see, it symbolizes the symbol of pi, 3.14, which is the approximate constant of pi. And then in this image here, we see other colleagues from Portugal who depicted the Pascal triangle and a nice theme or a special characteristic that we can pick up from a Pascal triangle is that it can allow students and learners to be able to solve any problems that have to deal with square or cube roots. And it is quite a fun pattern to create due to the triangles that are formed inside the pattern. And then in this third image, or the final image about showing how mathematics unites us, we've got young ones from Germany, and they are showing a picture of a fraction, 1/3. There's a young toddler on top and 3 of his folks at the bottom, which symbolizes a third, a fraction. And then the second theme that was discovered from the photo challenge would be landscapes. And here is a picture that was submitted from Portugal. And this landscape symbolizes or shows parabolas. In particular, this parabola we see here would have a parent equation of y is equal to minus x squared. And how most of my math teachers would say that this is a frowning face. And if the grain was positive, it would be a smiley face, and it would be the opposite direction. And then another image that was submitted from Indonesia shows triangles that are formed on the bridge. And the young lady over there can easily indicate and show to us the triangles that are found inside this bridge. And this is one of the last photos that would represent the landscapes that we have around us and our colleagues have submitted from across the globe. And then in this image here would be the theme that introduces mathematics everywhere. This is a structure on a building found in Portugal, and it depicts a right-angled triangle, a very special triangle for most mathematicians. We can do lots of cool calculations with this, and a calculation or a theme that is very unique to a right-angled triangle would be the theorem of Pythagoras. And a lot of calculations can be done from that theme. And then also another image that depicts where we can find mathematics everywhere would be just on a living organism such as a snail, as we can see. And this photo was taken from Turkey. And it is also linked to the first image that we saw about the spiral formation. And in here, we also have a spiral that forms on the back of the snails. And also, there's also the special ratio or golden ratio, which I spoke about, of a figure of about 1.618. And these were the themes that were highlighted this year in 2022. Thank you so much, colleagues.
Thank you very much, Bulana. Thank you very much, Amy, for your conversation with us. I guess these are some of the things that we probably would have to start thinking about in terms of, particularly you and I being teachers, we teach these things in class. How do we possibly make it more concrete to students? I think there's every reason why we probably have to think a lot more when we're presenting issues of mathematics. And hence it has also in the past created a division of pure maths, the need to move beyond pure maths to applied maths, educational mathematics, and so on and so forth. So, well, I wouldn't want to keep us waiting. I guess if we can speak to all of the teams, then once we're done, we would now have a little bit of time to discuss bits and pieces of what we wish to, so that we don't spend so much time on one particular team. Otherwise, I think I'm sure the other colleagues are good for now, and they might have noted some few questions. I think I've noted one. Probably I'll come back and ask you, Ms. Amy and Bulana. So our second speaker, if you are ready, why don't you share your work with us if you are ready? Ms. Asire.
Good morning.
Angalo. Yes, good morning. Good morning.
Good morning to our Deputy Dean, all our doctors, professors, lecturers, fellow student teachers, and attendees of this seminar. I am Nelisa Mandela, and I have the pleasure of delivering our chosen theme for Africa with Ms. Asive Galo. Our chosen theme of Africa being the contribution of Africa to mathematics and the application of mathematics in Africa throughout history. Ms. Gallo and I enjoyed this topic particularly because it allowed us to see and increase our identity as future maths teachers in how our subject has been developed in Africa, where we are also born. Archaeological evidence gathered in Africa has let us know that African people were the first people in the world to count. The tally stick, which was found in the Libombo caves in South Africa 35,000 years BC, had 29 notches cut into it, indicating that something was being counted or measured. Another artifact that was found was the Ishango bone, which was found in the Democratic Republic of Congo, which dates back to 20,000 BC. It is the oldest evidence of advanced mathematics. We can then conclude that Africa is the home to the world's earliest known use of measuring and calculation, confirming the continent as the birthplace of both basic and advanced mathematics. In writings about the history of mathematics, Africa's contribution is not highlighted as much as other continents. I quote from a paper titled The History of Mathematics in Africa. Most histories of mathematics devote only a few pages to Africa and ancient Egypt. An article released in November 2007 titled The Role of Mathematics and Scientific Thought in Africa gave great insight in the topic. The article refutes the theory that Africans had no intelligible sense of numeracy before contact with the West. It acknowledges that knowing and speaking of the long history of mathematics and science thought in Africa is a step in foregrounding African ways in knowledge production, human and social development, and towards the realization of the African's Renaissance. To speak more about this, Asive Gallo will continue.
Just a second, I'm sorry to interrupt you. I'm not sure if you wish to share your work with us, that is if you have it, but if not, you can proceed. I'm not sure if you had the intention of sharing your work with us on the screen, but if
Ms.
not, you can.
Gallo will proceed, yes.
Okay.
Good morning, everyone. Unfortunately, we do not have any work to share on the screen as we did not have enough time to prepare a PowerPoint. So mostly our work is just going to be verbal. Okay, so I will be continuing with the application of maths in Africa through the use of some articles and readings. So it goes as follows. According to Zaslavsky, 1994, Africans had developed counting systems and systems of weights and measures for trade and other purposes. They must have employed mathematical principles to construct their massive buildings as well as their more modest homes. They had used geometry to design lovely textiles and other works of art. We can use this statement to argue that even though it has been argued that there is no written proof of Africans having a hand in the creation of mathematics, because their contribution could be argued that it was more application than it was lengthy theories about the subject, which we have grown more accustomed to. The author continues by proposing a subject which describes the application of mathematics in Africa, dubbing the subject African socio-mathematics, stating that the topics discussed may have included numbers and numeration systems, beliefs about numbers, applications of mathematics to measurement, record keeping, and trade. The geometry of architecture, form and pattern in art, mathematical games of strategy, and games of chance. All these listed components are usually seen as the more or less orthodox forms of mathematics, as the usual standard refers to the more intricate theories which would revolutionize the development of mathematics, contribute to the rise of technology, and drastically change people's lives. But her focus in the subtopic evolution of Africa count mostly focuses on the development of the application of the subject in Africa, as seen in their day-to-day lives. The author reveals that a Donald W. Crowe, now mathematics professor, was on the rise in the early 1960s to contribute to an organization which had hoped to bring new math to African countries. He was formerly a mathematics teacher in Nigeria before moving to the USA. However, his collections of materials based on local mathematical principles were rejected by the organization because they were deemed as too unsophisticated. The author goes on to describe the different counting methods between African cultures and European cultures and highlights that different societal groups develop their own particular mathematics in different ways. Some of these cultural methods made their way onto the mainstream education system, such as the Roman numerals. Another reading from called Mathematics in African History and Cultures by Paulus Gerdes and Ahmed Jabbar in 2007. Although this reading mainly focuses on giving credit to African contributions to mathematics throughout history and actual examples of mathematics used in Africa, there are some examples of non-household mathematical contribution. The authors begin with a controversial statement. We are already at the beginning of the third millennia, and yet one is often struck by attitudes largely based on ignorance towards the mathematical contributions from Africa and by Africans. They go on to say that often the involvement and impact of Africans on life developments outside of Africa, especially in developed countries, are knowingly and unknowingly underplayed or even ignored. Examples of such accomplishments include contributions of African mathematics and astronomy, time reckoning, and calendars, and other examples such as string figures and board games. They touch on the importance of Africans, especially the younger generations, being aware of the contributions Africans had to math and science. So in conclusion, according to Hon Gonoi 2005, mathematics is a very useful subject with firm roots in African history. For thousands of years, Africa played a leading role in the development of mathematics in the world. Then argues that the mathematical heritage of our own continent was obscured during the colonial period and has to be recovered and valued. According to Paulus Gerdes 2010, he proposes that the study of mathematical ideas from African history and cultures may broaden the horizon of future mathematics teachers and increase their socio-cultural self-confidence and awareness. Thank you.
Fantastic. Fantastic. Nelisa and Asiv, if I'm correct, bear with me with the pronunciation. Let me just say this. Honestly, I wish if I'd known that you would have done this, I would have actually been invited you in my class. I think my third year class for you to give this talk to them, because I've been moaning and sort of talking about this time after time in my last lesson. As this being part of the lesson, I thought in the past weeks, I would say a couple of weeks or so. So, well, thanks a lot for this conversation and highlighting some of the advances and some of the prejudices, I would say, associated with the developments of advances in Africa. Great people are doing a great job here, just like you just said, and look forward to me inviting you in my class to possibly give a talk if you guys can. Well done to you guys. You're doing a great job, and we look forward to even more than that in future. We now move on to our third speaker. Thank you, folks. Well done.
Please confirm that you can still hear me right now.
Yeah, we can, I suppose. Good.
All right.
I can see what you've just shared.
All right. Thank you very much, sir. I greet you, Prof. Bayaka. I greet our Deputy Dean, Dr. Mora, our HOD in Senior Phase and FET, Dr. Satora. I greet all the doctors that are here in the meeting. I greet all ladies and gentlemen, which are all subsets of all the people who are here in the meeting. I am going to be talking about the resources that are available to celebrate and take part in the International Day of Mathematics on behalf of my group members, which are Sipum Zongamtweni, Requelin Plakis, and Sibulelo Zokolo. Now, please hear me correctly when I'm saying I'm going to be talking about the resources that are available to take part and celebrate the International Day of Mathematics. Analyze something that might be available towards you, might be not available towards me. So which means we sort of outlined some resources that we think might be available, but in addition, there may be some resources that we did not list here, right? So we can use mathematics games to celebrate mathematics and worksheets, PowerPoints, posters, puzzles, and some softwares, and some simulations such as effect simulations, right? So suppose that you want your learners to play, you see, this is a puzzle of which you can simulate or allow your learners to play with. You see, when you rotate it, you want your learners to have some certain picture. Né? You want them to analyze, to have, you see, maybe put all these green cubes together or squares together into this whole cube. Né? And then again, you see, these are the ones that are dominant here. Squares that are dominant in this whole cube are red and yellow. So you want to arrange yellow and reds together, you see? So you can allow them to play. This is just an example of a game now that you can allow your learners to play. And then now, I did not introduce myself. Who am I before I speak? Lo thethayo ngunyatha emnyama edla amadoda usobhalabhala amadoda ohlonje njengomntwana umsengo ophaphazela odlwana zimbuzi kwabhentswa wabhentsela entlajeni kwaPhumalanga ndikothe abakwaNomandla thumbela ovezi. Yeah, the reason why I'm mentioning who I am, because now I am introducing the indigenous games. So we have to, whatever we do, we must link with our own context so that we see our belonging towards mathematics, and then we celebrate them. Okay, from the first picture here, it was me and my colleagues from intermediate phase, which is Ayanda Mahashe. Then we're playing Unompuca. Some will say it's because we're playing with stones, and then some they will say Unompuca in Sixhosa or Umapic. It depends, because even Sixhosa is very diverse. It will depend according to how you define it, right? So over there we have stones. Unfortunately, they cannot be clear into this cardboard. We have stones that are there, a certain number of stones. And this is the stone that we are playing with, throwing it up, and then you will draw a surrounding on that box to just take out those stones and then take it back, and then leaving another ones outside that round. We say that play is an umapuca. Yeah, now, which mathematics topics can we link this type of play? Because whatever we're doing or we're playing, we have to link with the mathematics now. Maybe it will depend, because we have different interpretations, right? We observe differently and we interpret differently. Some will link with this play that is here on this first picture with the classification of numbers, you see, or operation of numbers, number system, or or operation of numbers. Because you can count, initially we had 0 stones that are available on that box, and then you start now, okay, we had 0, and then we have certain number of stones starting from 1, right? Say 1, 0. Okay, when we had the zeros, when we had no stones, we had the 0 stones, right? So we introduced some stones, and then starting from 1, 0, 1, 2, 3, 4, 5, depending to how many stones you have, of which is, you can talk about the whole numbers there, you can talk about the natural numbers, you see? So it depends, whatever you do, you have to link with a certain mathematics topic. It will depend again according to the grade, yeah. And then when it comes to here, the picture on the right-hand side, these people are playing with sticks in traditional costume. Why I am saying they are playing? You cannot fight with a smile on your face, right? So here they are playing maybe into a particular ceremony, but wait a moment, observe a little bit. What can you notice here on this picture without even reading what we wrote here? You see, check these sticks. What you notice on these sticks, maybe you can notice that this angle and this angle are equal. This angle and this angle are equal. Why? They are vertical opposite angles, right? Which links to Euclidean geometry, right? So you can do everything that is available in your context, but that will link to mathematics. And at the same time, these fighting sticks are not equal in size. The one that is in this hand and the one that is in this hand need not to be equal. It is a rule there in rural areas that we say they need not to be equal. So why do we say they need not to be equal? We take into account the measurements, that this one must be longer, this one must be shorter. You see, we are doing measurements even again without even having that awareness there into our different context. And the aiming, you see this man over there, it's aiming at a particular angle. The angle of elevation of this man and this one might be different. You see, by that way, you can link the trigonometry. But remember, as I said initially, that our different interpretations might be not the same because we observe differently. We have different opinions, you see, because we are different people, right? And then we said, this can be linked with measurements or geometry or trigonometry and so forth. You can add. And you see, yeah, this is what I've been talking about. And then now why we promoted indigenous knowledge? Because we wanted to see ourselves as South Africans. South Africa is very diversity in terms of languages, in terms of cultures, but we want them to be all present there as promoted in the CAPS for mathematics. That wanted to promote these games on the International Day of Mathematics so that our learners have a sense of belonging. That even when we are doing these particular things at home, these are the things that we also learn in mathematics. And at the same time, these types of games can promote the acquisition of mathematics concepts. You see, so whatever we are doing, we have to do with an aim of promoting the conceptualizing of mathematics concepts in a positive way, so that our learners enjoy and we enjoy while least we are teaching them, right? So kuthiwa kwaXhosa ke umbe ngomde uyawucika umlilo. Mandiyeke apho ke ndithi xa kwalo mzuzu xa kukhona comments, I'll be willing to take them with my colleagues and with the assistance from other colleagues. Thank you very much.
Thank you very much. Thank you very much, Nyati, Subulela, and Zukulu. Well, look, as we discuss these things, both in class and outside of class, of course, your presentation seemed to also have solidified the notion that you really appreciate the need to incorporate IKS, which is a huge field that you would find some of my colleagues have always been telling you, making disclaimers in class regarding what I've done and what I haven't done. A huge field that some of my colleagues are in, full of IKS, Indigenous Knowledge System, which ties closely with the second speaker, which I'm happy you guys are, as teachers in training, you guys are busy really talking about that. And possibly we might not be able to solve the problem today, this month, this year, 2 years, 10 years time, but gradually we'll get the problems resolved. So really great. I salute you guys for your endeavor, your great attempt and educating us on this. And I'm hoping that you just don't speak about this here in this forum, but speak about it and incorporate that in your teaching as you guys go back to your schools. Great job, right? Keep it up. Actually, our Deputy Dean has also sent something in relation to that, and I'm quite appreciative of that. And our head of department is also appreciative of that. Keep it up. Like I just said, she also just mentioned the fact that Indigenous knowledge system in teaching is a great idea. So folks, great presentation, keep it up, all right? I'm sure colleagues have questions or comments here and there, but that will be when we are done with this. You simply just mention the presenter's name and possibly pose your question or pose your comment if you want. But otherwise, I would say great job, folks. Great job, great job. Let's quickly see who is next in line. So we now have to move out of Faculty of Education a bit and get into Faculty of Science. And we allow Dr. Martin to share his views on us regarding facts about the importance of mathematics. So Dr. Martin, we are all yours. We would love to hear your views regarding facts about the importance of mathematics. And I'm pretty sure it cuts across all fields. Thank you very much, Dr. Martin. We are all yours now. You can possibly share your screen or talk to us.
Thank you very, very much for allowing me to give this presentation. I'm going to share my screen with you. Can everybody still hear me and see this and see the title slide?
Yes, I can. From my side, I can. I'm sure others would.
Thank you. Thank you again very much for allowing me to give the presentation. Just to introduce myself, I'm sure my first name is Martin, my surname is Weicht. I'm from the Department of Mathematics. Okay, I just will give a short presentation about the applications of mathematics or how it fits in generally. First of all, just to discuss what pure and applied mathematics is about. Pure mathematics is more about the development of theories of mathematics for its own sake. So, for example, unraveling the properties of the real numbers. What exactly is a real number? We tend to think we have that all figured out. But it took a lot of great minds actually to figure out exactly what is a real number and what are the properties. So the idea then is you start with the concept or you start with the definition, and then using definition or basic axioms, you then go and prove theorems. And then from those theorems and the basic definitions, you can prove more theorems and so on. And thereby you build up a whole theory. That's how this is in a nutshell what you do in pure mathematics. Applied mathematics is actually more about the applications of existing mathematics to solve real-world problems. So, for example, we've already seen some hidden applications there already in some of the previous presentations. So I would also like to discuss a few more of the applications of mathematics. So the idea is you use existing mathematics, mostly pure mathematics, and then you'd go and solve some real world problems with this. So that's what applied mathematics is. I'll give an example in a short while. For example, Newton's theory of gravitation and the development of calculus. Sir Isaac Newton discovered that actually the very same force which keeps us firmly on the ground is actually the same force which makes satellites go around the Earth or planets go around the sun, and that's gravity. But at the time when for Newton to have made this discovery, he had to actually develop and invent the mathematics required to actually solve or make the discovery, and this is calculus. The mathematics at his time wasn't yet around, so he had to invent the mathematical tools to do it. At the same time, then calculus forms part of pure mathematics, and it's now part of pure mathematics, but at the same time, it's applied to a variety of other disciplines, such as engineering, biology, and economics, and the world of finance. It's a subject which developed with having applications in mind, and then it formed part of pure mathematics again, and then it goes back into further applications. So already one can see over here that there is some symbiosis or interplay between pure and applied mathematics. The two actually start feeding off each other. The applications can bring about further development of pure maths, that is the development of theory and mathematics, and then it can get plowed back into practice. I will actually return to this somewhat later. Also, if you look at string theory, it's actually one of the best known theories which physicists have in actually forming a unified theory or quantum theory of gravity. And it unifies all four fundamental forces of nature. So gravity, electromagnetism, the strong nuclear force, the weak nuclear force. And it's mainly algebraic geometry and differential topology through what we call these Calabi-Yau manifolds, which provides the basis for string theory. This is actually the reason I mentioned the second bullet here is that this is really pure mathematics, which first developed on its own just for the sake of theory, or it had certain theoretical motivations in mind, but then physicists came along and actually saw how it gets used in string theory and in solving some of the deeper questions in physics. And then some developments in string theory actually led to the solution of an unsolved problem in Calabi-Yau manifolds, a pure mathematics problem in algebraic geometry. So you first had the algebraic geometry side of things, the Calabi-Yau manifolds, they're feeding into string theory, the applications of physics, and then later on, the physicists solved a problem which then actually led to a solution back into pure maths. So it's almost like pure math and applied mathematics are not actually as separate as we think they may be. You've got the two feeding off one another. Again, just one more bullet point. There's therefore a strong interplay between pure and mathematics and theoretical physics. Lastly, or second lastly, I should say, just going to the moon back in the 60s is actually a need for rigorous mathematics, or at least some type of theory in practice. Let's suppose, okay, the Earth is over here, the moon is over here. So you basically would launch a satellite from the Earth, it goes toward the moon, and it would rendezvous with the moon, go into orbit around and a few times, and then it would come back to Earth again. Now, to calculate these orbital trajectories, it actually goes right back to calculus and the theory of gravitation of Newton. But if we think about what Newton had actually done, he thought of it very, the concept very intuitively, which is what he needed to come up with his theory of gravitation. But a lot of what Newton actually did to come up with gravitation, a lot of it needs to be made mathematically precise, such as the concept of a limit of a function. It has to be made mathematically precise to calculate these orbital trajectories, because especially with the onboard computers with the Apollo missions, and especially back on Earth, back at Mission Control in Houston, if you had to tell the computer how to do a certain calculation, you need to give the computer precise instructions. Precise instructions. So for that, we need precise mathematical definitions of the concepts involved, such as a limit, and not only a very, very rough idea or intuitive concepts which we can form in our minds, but we need to make it mathematically precise. Otherwise, if the orbital trajectory is not calculated accurately, then over here's the sun, then Neil Armstrong would have maybe been sent around an endless journey around the sun. Also, a lot of numerical analysis is used. So that actually is the science or mathematics of doing the number crunching properly. Your calculator or your computer does rounding off errors. And now you need to know actually what effect do rounding off errors have in the next stage of calculation and so forth. We need to manage all these errors which accumulate. And that's what numerical mathematics is actually all about. All right, lastly, some further applications in financial markets. So if you go, for example, to the JSE Stock Exchange, there too you use a wealth of mathematics and even very abstract mathematics. I don't know how familiar you are with it, with things like functional analysis, for those of you who are familiar with that, or things like measure and integration theory. It's also pure mathematics, but it gets used in the financial markets. So that's one application there. Also biology, such as cell biology and genetics. Combinatorics is very important here. Even sports scheduling. So for example, if you need to, things such as a tennis match at Wimbledon, and you need to do the scheduling, that maybe is not such a simple problem as we think it is. And it involves things such as graph theory. So you've got a graph consists of a set of points connected by edges, which you would draw on a piece of paper. And that's the subject or the mathematics behind the sports scheduling. Forecasting, such as weather and tsunamis, that's also where a lot of mathematics gets used, especially numerical mathematics and calculus. Even subjects like data compression. And this involves more discrete mathematics. And lastly, cryptography. Cryptography is mainly that branch of mathematics which keeps all your money securely in the bank, for example, so that nobody can hack your account or whatever. So, and sending, let's say, for example, a secret message from one person to another in encrypted form so that no one else can intercept it. What gets used actually here is number theory. And that's the study of prime numbers, amongst other things. So just the theory of the study of the whole numbers, especially the prime numbers. Again, that sounds like very pure mathematics, but eventually it gets used in things like cryptography, so that our money is kept safely in the bank. And when you do internet banking, that no one else can actually see what banking transaction you are performing at that moment. Or you want to send a secret message to the White House, send it in encrypted format. Okay, this actually does bring me to the end of my presentation, except that I would like to mention also that you can actually go to the following website in order to see more applications of mathematics. It's ams.org, and then you go /mathmoments. There you can find, you can read in very simple terms about a wide range of the applications of mathematics in everyday life. This brings me to the end of my presentation. Thank you very much for your for your attention, and also thank you for providing me the opportunity to give the presentation.
Okay, Dr. Martin, see, I'm so excited, I don't even know what to say. Isn't this, those of us, especially I'll say mathematicians in training, or possibly our pre-service teachers and our in-service field teachers who are here, and those of us doing our studies in the field of maths, whether education or whether it's applied maths. Isn't this insightful? Of course it is. But first, of course, I must say really big thank you to Dr. Martin for this presentation. It's just, I've always been, it's always fascinating to me. I mean, being in the field of maths, bits and pieces of it here and there, depending on sometimes what I do. He's mentioned quite a lot regarding the applications of mathematics. I remember when I first wrote this email to my deputy dean and my HOD, if they do recall, I joked in a line and I said, we all use mathematics. We all are consumers of mathematics. This is precisely what I was talking about. I mean, it's pervasive. It's virtually everywhere. And I couldn't, agree to anything less than that. I mean, he's just mentioned it all. Right through physics, astrophysics, it cuts through financial mathematics. The entire blockchain industry, those of you who are into blockchain industry, or you might loosely call it cryptocurrency and stuff. Well, the entire blockchain field is dependent on this cryptography. If you have a bit of idea as to how blockchain works, you would understand, you appreciate number theory and cryptography. Those of you who intend to work in econometrics, or at least have done some material science and finance, and so you've done some econometrics, you would appreciate what Dr. Martin is saying. The entire econometrics seem to be hinged on the field of mathematics, AI, data science, mention them. So look, I'm sure if we were to give him the entire day, he will blow our minds off. Trust me, there's so much that he can say, and I'm fully aware of that. Well, let me not take much time and to say thank you again for your information, your presentation you've shared with us. Great, very lovely, and we look forward to interacting with you during the question and comments time, and possibly you would even also share some of these things with us, especially in the Faculty of Education, where we tend to train teachers to teach these things. Sometimes it's a bit difficult. If I share my own experience with you, when I first told a colleague that I was going to pursue maths and later to do actuarial science and stuff, the comments I actually got. But eventually I proceeded and it did help me. So, well, let me cut it short and say thank you once more for such an insightful comments, even coming from our head of department also, and Dr. Vianney as well. So we will hope to have interactions with you again at a later date. Well, if you allow me, move on to our next colleague. I'm sure it's Dr. Vianney again, actually, who will be talking to possibly Team 6 and Team 7, that is the Maths Clubs for Africa, as well as the birthplace of mathematics in Africa. So Dr. Vianney, I guess you will be able to speak to these two simultaneously whilst we listen to you before we move on to our honorable HOD, Dr. Eloise, who would sum up everything. That's the 8th team. Thank you. Dr. Vianney, if you are ready, please, we are all yours now. We would be glad to listen to what you have.
Good morning, just a minute.
Right.
Okay, a good day, everyone. It has been very rewarding to listen to some of the speakers that we've had today, and to see the students taking part in the manner in which they've done today. And it does show us that it does seem as if mathematics education is in good hands. I'm going to be talking about maths being fun. Well, for some people will say, but is maths really fun? Not everybody will agree with you if you say that. In fact, many people will tell you that they hate maths. Now, as maths educationists, as people involved in the maths discipline, we constantly looking for ways of making the subject fun for learners. So I'm going to be talking a little bit about some of the strategies we could use to possibly achieve this, which will also form part of the sessions that we hopefully going to have every month that Professor Bayaga talked about a few minutes ago. Yeah, there's a lot that we've learned from the last few speakers, definitely. Now, I'd just like to start off this talk by firstly giving you a short brain teaser, if you like. I'm sure some of the students that who I teach have already seen this, but that's not, we're just trying to show that look at some of the activities that we could do to make mathematics learning more fun, through play. So that's the key. That's the key word for me today, that we're going to be looking at play. Yeah, can you just do this quickly for me? Those students have already done this before, they can, but I just want to give everybody a chance to be able to experience this and to talk a little bit about what we can do about it in our classrooms. Can we give you 1-2 minutes for this? Take any number of the month in which you were born. It could be, if you're born in January, that's the number 1. You don't even need a calculator for this. If you're born in December, unfortunately, you're going to have to work with a bigger number, 12. 12 multiplied by 5. The answer you get, you add 6. And then you multiply the answer by 20. Remember, multiplying by 20, you multiply by 2, just add a 0 at the end. Minus 15. Add the day of the month. Day of the month is the date on which you were born. So, for example, if you were born on the 15th of January, that date will be 15. So you add the number 15 if that's your date of birth. So all of our answers will be, most of our answers will be different. Then you give your answer to the facilitator, and that's me. And then I just want to share something about this from a mathematical point of view. What does it mean? So can we just give you 1 minute? We don't have enough time, unfortunately. Under normal circumstances, you get more time. So if you're ready, you could just give me your answer. You can just write it down there somewhere for all of us to see. So somebody got 629, and that means their date of birth will be May 24. Can you confirm if that is correct? Assuming that you've given us the correct number, of course. If your answer is 1033, then your date of birth is 1023, that could be September the 28th. Okay, I don't see those people saying yes or no.
That's correct. That's correct. You have to tell me what you did.
Okay, I will tell you in a minute. I will in a minute. 219, that's January. Okay, the 219 has disappeared now. But if it's 219, that will be January the 14th. If it's 635, that will be May the 30th. Yeah. So I'm going to talk a little bit about how I got the answer. Normally, I shouldn't be doing that. I should allow you, give you enough time to struggle, because that's where the learning comes from, not from me telling you the answers. Okay. Can we just one last one on 635? That's May the 30th, I would say. Yeah. Okay. Now, you're going to need a little bit of mathematics to be able to arrive at the answer here, of course, but let's just look at it this way. Okay. Now, what you've just done could be reduced to an algebraic expression, which is what we have on the screen right now. Let's tell me if you agree, because when 5m, let's multiply the month by 5, that's 5m plus 6, multiply by 20 in that order, minus 15, plus the date on which you were born. Okay. Okay. So quickly, if you, sorry, I just want to give you an example. It's in reading views. Since we're in the maths, working with maths people here, I can't just say that was magic. We need to say why it works. So I want to talk about that just now. Okay. Okay, suppose your answer was, I wish we could use one example. Okay, let's just use this example. Let's say your answer was, after doing all of that, your answer was 220, for example, 220. It could be anything. Now, can you just, now we need to solve for m and d in this equation. So you need some knowledge of linear equation, how to solve an equation. So if we just go through that quickly, if you simplify that brackets first, we know BODMAS. If you multiply everything inside the bracket by 20, what do you get? I want to write here. Yeah, you get 100m plus 120 minus 15 plus d equal to 220. That was my answer. Yours will be different, of course, depending what your answer is. Now, can we continue to solve this, to solve for, if we transpose, take 120 minus 15 will give you what? 105. So we have 100m plus 105 plus d equals to 220. Okay. Now, the next step is 100m plus d. That will give you what? That will be equal 220 minus 105, which is 115. Okay, now can you tell me if 100m plus d is equal to 105, who can tell me what is m equal to and what is d equal to? I think we used to working with x's and y's. So if we say if 100x plus y is equal to 115, for example, what is x equal to and what is y equal to? Is anybody able to give us the answer for that? If there's a comment, please let me know. I'm just looking at my screen right now. Anybody able to tell us 100m plus d? Yes.
Hello, Doctor.
Yes, please.
I think m can be 1, and then d becomes 15.
Exactly, and that's my date of birth. That's January the 15th. So what do? If you give me the answer, I just minus 105 from that answer. And I look at the hundreds. The hundreds will give me the month in which I was born, which is my case, January. And the D will give me the 15, which is my date of birth. So it can be explained mathematically. So that's the good thing about it. Okay. I don't know if Heloise is happy. but I'm sure we would need more time.
Yes, no, I understand how you got to it.
All right, thank you very much. So I just thought I would look at some examples of some of the activities that could be done in which I would like to propose at the Maths Club. Okay, we did make an attempt with the students just before COVID to form in the education faculty to form a Maths Club for the education faculty for maths education students. And some of the students who are here now in this meeting also took part in that. So I would encourage that going forward. And then here's something else that is not very obvious, because if you give me this answer, I wish somebody could tell me the answer now again. If you have this, we have a problem of students just using a calculator just about for anything these days. If you work with some of the young people in high school, but we can do this without a calculator. Would you agree? Can you look carefully at what I'm doing and tell me how I got the answer for this without using a calculator? You have to trust me that I'm not using a calculator, because there's going to be a pattern involved. Okay. And we're also going to talk about the why. Do you agree that's the correct answer? You can check with the calculator. Of course, it must be the correct answer, but why? What am I doing? Can anybody tell me to get the answer, and why? Just for the benefit of those people who have never done this, I'm sure some people have done this and they know what is going on. But can anybody explain? Can you see anything? Any pattern in what I was doing just now?
Yes, Dr. Macha. It
Yes.
looks as though the numbers above are divided by 2 to get the ones below, and a 0 is added to the end.
Yes, half of 4 is 2, half of 2 is 1, half of 8 is 4, and you just carry on like that. So just find half, and then you just put a 0 at the end. But why are you doing that? Why put a 0 at the end? And why divide by 2?
Is it because 5 is half of 10, and if you were multiplying by 10, you would have then double everything?
Yes, that 0 at the end is just multiplying by 10. That's easy. If you multiply by 10, just put a 0 at the end. If you say 7 times 10, you just put a 0 at the end, you have 70. And then divide the whole thing by 2. That's where the dividing comes from. Okay. So I thought I would just look at those two. I don't know if we could call them brain teasers. Maybe the maths, Dr. Beck will probably not agree. But to just develop this love of mathematics, and so that we can really have fun in mathematics and not just say mathematics is fun. Okay. Okay. Now, having done that, within the field of education, what are some of the things that we could do to make mathematics more fun? In one of the TED Talks, you probably have heard something about that. Dan Finkel talked about 5 principles of extraordinary maths teaching. I'm not going to be looking at all of them. I'm just interested in the last one. Just going through them quickly, you start a lesson with a question rather than an answer. Get your learners to think right at the beginning of the lesson. Let your learners struggle. Remember what I said about that problem? Normally I would let you struggle because that's where the learning comes from. You know the answer key. You're not going to have all the answers. It's possible sometimes as a lecturer or teacher that you don't know the answer. And that's perfectly normal. And then say yes to your answers. Just saying yes doesn't mean I agree with what you're saying, but let's talk about it. Prove to me that what I'm saying is wrong. If I say to you 1 + 1 is 12, can you show me that it's not true? And he actually gives an example of that. And the last one is play. And that's where the focus of this short presentation is on play. Maths is not about following rules, because that's what we taught. We taught to memorize the steps. And then once you know what the steps are, you get the correct answer, you think you're done, then you know the mathematics. Until you get to university where you've got to think more broadly about these things and the problem starts. It's about playing. That's what he's saying. Most of the discoveries that have been made is through playing, such as pi, for example. How did they discover pi? Measuring the distance around an object and dividing by its diameter it became interesting because it always gave them the same answer. It was roughly about 3.14. That's why we have Pi Day today. We're celebrating that day. So maths is about exploring, about fighting, well, hopefully not physically, looking for clues, breaking things. René Descartes, you probably have heard about this statement that René Descartes is known for, I think, therefore I am. And René Descartes goes on to ask the question, but what is a thinking thing? He says a thinking thing is one that doubts, that challenges things, that asks questions, that explores. And that's what we like to promote. And that's what play hopefully does. Play shows the beauty of mathematical thinking, not memorization of disjointed mathematical facts or passive rule followers. Math learning flourishes in homes where games are played. Can you see? That's an interesting fact. That games, there is mathematics involved in playing games. That's why I'm very interested in what Nyati was saying about traditional games and the mathematics involved in them. It won't sound so strange when a child says, I love maths. I mean, because most of them say, normally would say, I hate maths. I mean, we all know this. Yeah. Okay. Now, just to talk a little bit about what Nyati discussed a few minutes ago, you hear two sticks up, people fighting, stick fighting. And I looked at those two sticks and he pointed out the mathematics involved in them. And something came to mind when he did that, when in ancient African communities, when they built a rectangular house, you've got to make sure that it's rectangular. Those angles are approximately 90 degrees or exactly 90 degrees. And how do they do that? Look at those sticks that Nyati had. They have to make sure that those sticks are equal, first of all, when they're building a rectangular house. And they put them across each other, as Nyati did during the stick fighting. And then they would join the endpoints of those two sticks. Automatically, those angles will be equal to 90 degrees. And the question is why? Anybody able to say why? If you join the endpoints, let's say you get more sticks or a piece of string to join the exterior points of that shape, two sticks cross each other as he had them, join the endpoints, you will definitely get 90 degrees. So there was mathematical thinking in ancient communities in Africa, as Siva and Melissa pointed out. Those angles must be equal to 90 degrees. Why? Because these are diagonals. Those sticks are diagonals of a rectangle, and they're equal. Because they make sure that they were equal. If those diagonals are equal, and they cut each other in the middle, in other words, they bisect each other, the angles formed at the corners of that four-sided figure must be equal to 90 degrees. So those are some of the theorems. Can you see? So it shows us that there was mathematical thinking involved in those ancient communities. So I'm interested to know what Nyati has in store for us with regard to that. Okay, I don't know how much time we've got for this activity. It's not a very long one. Here's, for those people who teach maths at school, here's an interesting activity that you could do with your learners. And I want you to your participation in this as much as possible if you can. Can you see those numbers from 1 to 60? There's something interesting about these colors that we have on these numbers. Are you seeing anything interesting about these colors? Anyone? For example, the even numbers. I'm trying to help you here, but I'm not supposed to do that because of the time factor. Can it say anything about even numbers? What color are they? What about the other colors? The green color, the purple color, the blue color. They all mean something.
Good morning, sir. For
Yes,
one, I
good
can
morning.
see that the even numbers all have orange, and counting in multiples of 3 all have green.
Yes, okay, good way to start. There's an orange in all the even numbers. Can you see 2, 4, 6, And no other numbers have have the orange color except the even numbers. But now what? What's the next question? What do you think the other students are going to ask if you say that? But look at number 6. It's not the whole counter, or if it's a coin that is orange, it's only part of it. The other part is green. What does the green represent? What do you think?
Doc,
yes.
I think the combination of those two colors at 6 is inspired by the color in 2 and in 3. Sort
exactly.
of a multiplication of 2 and 3 to get a
2 and
6.
3 will give you 6. That's why we have the green color and the orange color in that counter. And so on and so on. We're not going to do all of them. For example, let's just do one last example. For example, 48. Why do you have 5 different parts? 1, 2, 3, 4, 5. 4 of them are orange and 1 is green. What is the green? What are those 4 orange parts? What number is that? Taking into account what you told us just now, because you're 100% correct, I agree. 48. What are the factors of 48? In fact, what are the prime factors of 48? I may not be able to see you, but I'm just looking at my screen now. If there's a hand up or something, please remind me. Yeah, but just in conclusion, just to, I'm not supposed to be telling you, as I said, it's important for you to struggle to be able to learn. But if you look at those 4 parts, the orange ones, that's 2 times 2 times 2 times what? In other words, what are the prime factors of 48? It's 2 to the power 4 times what? The green part will be the last part. Okay, maybe we should give that to you as homework. But the important thing here that's being discussed is that you need to get your learners to play with mathematics. Can you see what is it that they learned? Yes.
Is a comment, Doc?
Please, yes. I'm listening.
Comment is about multiplying 2 4 times and then multiplying the answer by 3.
Exactly. And that will give you 48. 100%. Right. I'm happy to see that you're part of this. In conclusion, with regard to this, some advice for teachers. So we might think about forming those maths clubs again. I'm happy to hear Professor Bayaga say we're going to be having this on a regular basis. Some concluding remarks would be teacher models a positive and excited disposition. It's important for teachers to do that. And then the learners will share in the fun. They need to see that you're excited about the subject. Find the parts of maths that you love and share joy with the students. Look for opportunities to keep play at the center of the classroom. So play should be an important part of what you do. Introduce games to students by playing them. We could see just now that a lot of them involve pure mathematics. Many of these games involve some mathematics, including the ones that Nyati showed us, the traditional games. So rather than just explaining them, I think I may be guilty of having done that today, but there wasn't enough time. Avoid false enthusiasm. Students know the difference. Remember how good an aha moment, those aha moments that come when you get the answer correct, when you are able to see that what the meaning of those colors is in the last activity. That's an aha moment, which everybody, which is difficult to describe. Develop your own relationship with maths, and the students will benefit. Play along when students try changing the rows, which is a good thing. When you change the rows. When I multiply by 5, many students will ask, but say, what if you multiply by 7? Will you be able to do that without using a calculator? And that's a good thing. If I can't, then I'll say, no, I can't. But I can do numbers. I can multiply by 9, by 11, and by 5 without a calculator. Thank you very much, as far as that is concerned. And then we will now go on to the next one. If you give me time to talk.
Yes. Thank you very much, colleagues, Dr. Macha. Look, I couldn't have said more to that. I guess it's indeed maths is fun in every respect. Not necessarily following rules, heuristics. We often are made to believe In fact, that your work it reminds me of a current paper I'm kind of, I would say, forced to write. I never really thought of it, arguing actually that maths is exploratory. And by that, I mean, we should begin to use phenomenological approaches in teaching mathematics and learning mathematics. And I guess your presentation seemed to sort of tie here and there with some of the things I've been arguing in the paper. And hopefully in the future, especially those of our colleagues in the field of using approaches using phenomenology, in which I'll touch base with you, we'll see how this thing works. So thanks very much for opening our eyes on this and confirming that we really need to move away from this heuristics approach in teaching maths, particularly our student teachers who are also here. Well, in order not to also keep us waiting, the last part of our session is very important because ultimately, whether you want to pursue mathematics as a teaching career or as applied or as pure maths through the hands of Dr. Martin, you still have to get through either the Faculty of Education or through Dr. Martin's hands. And that was one of the key reasons why I sort of said it would be important we have our head of department here to give us some few information about what we are doing and hopefully encourage, like I said earlier on, of course, we are not expecting that today, tomorrow, this month would make us pick up in the uptake in maths. But as we keep on gradual, by the end of the year, next year, we'll see how it goes. And so even though I'm saying Dr. Heloise, who is the head of department, would speak on our PGC program related to maths, I will also be so glad to have Dr. Martin share anything that he thinks needs to be done over there, or how we would love to kind of encourage folks to join the two faculties and particularly the two departments in terms of maths. So, which is why Dr. Heloise is speaking to us. And the intent is that by the time we get to where Dr. Heloise is, we would have a good number of us still here to listen and spread information, help us spread information regarding what we do in our PGC, in our department, not just in our department, but Dr. Martin's department. Because as you move forward, trust me, the numbers get to dwindle. We don't have many of us doing maths, STEM, and so on and so forth. So, well, I'll leave it at this point. The head of department knows better than me in this particular area also. So please do help us to understand the need for us to have folks getting into maths and STEM. Thank you very much, colleagues. Dr. Louise, we are all yours now. Thank you.
Good morning, colleagues. It's just 10 minutes still of the morning left, but I'd like to take the opportunity to, first of all, say thank you very much to Prof. Annis for initiating this. I think it is long overdue, and for getting us to spend some time, thinking about the importance of maths, and also getting both the Faculty of Education and the Faculty of Science to collaborate on this. This is the beginning, I hope, of more things that will come with regard to this, because I think it's vitally important for us, for the two faculties to work together if we want to bring about change with regard to maths in our country and globally. And I'm going to fail myself if I don't say anything about the wonderful presentations done by the students. It exhibited, to me, illustrated to all of us, I think, the love and the passion that you have for your subject. And that already for me is a plus in terms of being a good maths teacher, because if you have a passion for your subject, you're going to instill that in your learners as well. So thank you very much, Prof. Annis and students, for your presentations. I'm a qualified accountant, but I have a love for maths, and, I did maths in my undergrad more than I was supposed to do because of the love that I have for maths. So I was very inspired listening to all your presentations today, and it just made me realize that we need to instill this love for maths in all our children. And let's live for our children, because they are our future. Prof. Annis asked me, to speak about the PGCE, but it's very difficult to just speak about the PGCE in isolation. So what I've done is look at education at large. And if you look at the picture of education at large, you will find overwhelmingly that, education is in crisis. So I've titled my presentation today, Education in Crisis, and how can we turn the situation around. Before I start, I'd like to introduce myself. Prof did mention that I'm Dr. Eloise Satora. I'm the head of department for the secondary school education. And in this department, the following programs reside. We have the B.Ed SPFET program, and we've got 3 streams for this program: the science, the commerce, and the humanities stream. The one where maths resides, or maths actually resides in both science and the commerce streams in these undergraduate programs. And then we also have the PGCE program. That's a 1-year postgraduate qualification, a teacher education qualification, where students who've completed a BSc or a BCom or a BA can come and do a teacher education qualification, a 1-year qualification to learn how to teach their specialization. So essentially what we do in this department is we prepare high school teachers to teach their specific subject specializations from grade 7 to grade 12. Now, I know a lot of you will think grade 7 is not part of the high school. Yes, it's not. But we offer the SP, and SP starts from grade 7. So that is why I've indicated there, from grade 7 to grade 12. In fact, one of my master's students did his proposal defense yesterday, and had a very, very interesting explanation of how these different grades link to each other. And he's focusing on maths and the use of language in maths as well. So if we look at teacher education in South Africa, one thing that is highlighted is the fact that we've got a scarcity of teachers. It comes up in several reports. One that was written by Nick Taylor, the former CEO of the JET Education Services Program, mentioned in 2020 that we had 418 qualified teachers in the country. This is to provide education to more than 13 million learners. It is predicted that by next year, we require 456,000 teachers. Look at the difference between 418 and 456. This should highlight the crisis that we're experiencing with regard to preparing teachers in our country, especially in subjects like maths and science. And the fact that we have a shortage of teachers then makes schools desperate. And what they do is they then manipulate the department to appoint unqualified teachers. And this just contributes to the vicious circle that we experiencing in our country of bad results, bad maths results. You'll see in my next slide, I allude to these results. Because the unqualified teachers that are appointed don't know how to teach. So they skip over certain important topics. They make the subject difficult for the learners. And this contributes to learners disliking the subject and not performing well in the subject. This despite government's attempts, to encourage students to study education, and specifically maths and science, by giving them the Funza Lushaka bursary. We're not attracting enough students because they're not performing well at school. And this Funza Lushaka bursary is actually a merit bursary. So we cannot give the bursary to those students with weak results and take in students with weak results to do education and specialize in maths and science. If we zone into the maths education, South African, the reports indicate that South Africa's mathematics and science education is ranked one of the worst in the world, and it continues to spiral downwards. This is alarming. You know, we're going to have to intervene. Yeah. There's just a statistic about the decline in the maths results, the grade 12 maths results. And what this basically says is this was the 2020 result that was 53.8% pass rate at grade 12 level, which actually means that half of our students, half of our learners who sit for the maths exam fails the maths exam, almost half of it. Because 53.8 means about 47.2% failed that maths exam. And we know, and today in today's presentation, it was made very clear that mathematics is part of our life. You know, it's part of everything we do. And so it's the gateway subject that is going to be considered for, you know, critical economic growth in the country. And if we don't have people that can do maths, obviously it's going to have an impact on the country's economic growth. So therefore, the continuing decline in maths teachers and subsequent student performance is a cause for great concern, and we're going to have to look at it. And that's why I'm so happy that we have these presentations and talks where we can look at, you know, what it is that we can do. We can ask ourselves, you know, why are there a shortage of maths teachers? And some of the things that come up is the vicious circle I spoke about. You know, the poor maths teaching at school, the lack of interest to pursue a teaching career in maths or any other career in maths, the global shortage of STEM skills. This shortage also contributes to people who do specialize in maths taking up other jobs rather than, you know, pursuing a career in maths education. Obviously, you know, one that is often mentioned is the poor salary and the lack of resources in education that makes working in that sector difficult. But an even more important question to ask is, you know, what can we do that's in the sector of higher education, that's in the sector of teacher education? What can we do to turn around the situation? And just 3 points. We can increase the number of qualified maths teachers that we send out, you know, to schools, and increase the number of qualified teachers in schools. So we have to recruit teachers for both the SPFET and the PGCE programs. And we have to enhance the quality. It's not about, you know, numbers and sending out a lot of maths teachers, but we need to send out maths teachers that exhibits a love for the subject, that understands the subject, that, you know, will ensure that good maths teaching is going to happen in our schools. So in our B.Ed SPFET program, the science program specifically, we have maths specialization. And what we decided is that to improve the quality of the students we take in, we increased our admission requirements for maths. If you wanted to become a maths teacher, you needed to have done maths at school, and you needed to have obtained 60% for maths at school. This is in line, obviously, with what the science faculty, Dr. Vich and them requires with regard to students wanting to specialize in maths. One of the other things we've been doing over the last couple of years is that we've had several conversations with the maths department to ensure that the maths curriculum is aligned with what teachers are supposed to be teaching at school level, so that they're equipped with the content that they have to teach. Yes, we agree that they shouldn't just be taught the content that they have to teach at schools. They have to be taught more than that, but there should be a very strong focus on the maths that is prescribed by the CAPS curriculum. And then obviously support these students while they're participating in the programs, both the BEd-SP FET program and the PGCE program, through tutorial programs, so that they can put what they're teaching in action, so that they internalize the content that they are taught, and then so, be able to transfer that knowledge to their learners. With regard to the PGCE Maths program, because this is the group of students that do their BSc in the science faculty with Dr. Vir and Prof. Aswandini as the dean there, and come to us after qualifying with the BSc and do a one-year PGCE program with us. Again, we've upped the admission requirement to make sure that we take in quality students into this PGCE program. The challenge we experience in here, Prof. Anis, and you can attest to this, is that we're not getting in enough students into this program. And we're going to have to work on this, whether it means we have to go into the science faculty and promote the program there to recruit students. We require a 60% average for the degree that they've completed, and they must have 2 teaching subjects up to NQF level 7 or the 3rd year level. These students are funded by Funza Lushaka. If they've completed a BSc and they've done maths and science, they're definitely going to get a Funza Lushaka bursary, because those are the areas of specialization that Funza supports. So we'd like to encourage, and ask the science faculty to also encourage the students to consider a career in education and to come and do a PGCE with us. Then my last 2 slides focuses on enhancing the quality of the maths teachers. This is something that we focus on for all our teachers, but I'm bringing it back to the maths teachers here because obviously today's presentation is on the International Day for Mathematics. And in our faculty, we embrace a humanizing pedagogy. And what this means is that we employ and we role model so that our students can also employ, in turn, teaching practices that intentionally utilizes the histories and the knowledges and the realities of students as an integral part of the educational practices. Nyati's presentation comes to mind, taking the context in which we live into account when we teach, our lived experiences, and so to cast what we know and our thoughts and the role players as critically engaged participants in the co-construction of new knowledge. This is what a humanizing pedagogy is. This pedagogy underpins our curriculum, our humanizing pedagogy curriculum framework you can see in the picture there. And it's guided, and we're guided by what we do in our teaching, by the 5 questions, the 6 questions that you see on the screen now. It's always important for us to have our students understand why they have to learn a specific topic. The question why, and how it fits into their world, their lived reality. Then, who is the student that we're teaching? We have to take into account the person that we're teaching, their knowledge, their background, where they come from, what they already know. So that leads to the next question. What knowledge does that student bring into the classroom of the topics that we're going to be teaching? What do they already know? Because they don't come into our classrooms as empty vessels. How do we teach them? The different methodologies and pedagogies, and this is where it comes, where I want to relate to Nyati's presentation earlier, and even Amy Lee and them's presentation. that we link what we teach, that we use methodologies to link what we teach to the lived realities and the lived experiences of our students. Where we teach is also important. A lot of people think that teaching is confined to a classroom, and that's not the case. And we saw that today in your presentations. And that's what we try and instill in our students, you know, that teaching can happen anywhere. You have to link the theory that you're teaching, the concepts, the content to the lived experiences of the learners. And finally, the so what deals with how do we assess that what we want these learners to know, that they actually know that. You know, we promoting and advocating to move away from these formal exams, to rather allow the learner to express and illustrate that they know how to use the content that you've taught them in a practical way in their real life situation. Colleagues, this is what we strive towards in the faculty. And, you know, it's not an easy task, but we have to continue doing this if we want to see the change that we dream about. I thank you very much, Prof. Annis, and students and colleagues. And I would like to wish everyone everything of the best for the remaining months of this year with this new initiative that you have started. Thank you very much.
Yes, you see, thank you very much, my honorable HOD. Now, I hope you guys, especially our students, you understand why she had to come as the last person to speak, even though our Deputy Dean will also sum it all up. She seemed to have tied it clearly when you look at virtually the first 4 or 5 speakers up to Dr. Vianney. She seemed to have made it very clear as to why we need to jack up our socks when it comes to mathematical skills or STEM skills. And those of you who tend to sit in my class, you'll be wondering why each time I get to class, I say, pull your socks up. You've got to study up to at least master's, or if you can do your doctorate, you do it, especially in the field of mass education and STEM. And you would see both of our heads of department have alluded to that fact and made it much clearer. And you will always be wondering why I keep hammering that point. Dr. Eloise, thank you so much, to a point where I think, I don't mind you repeat your session each time, each month, if we come as different folks come in, because this is precisely what we want to be seeing, hoping that we would really understand the need for more mathematical skills. And Dr. Martin, in future, we hope that this would continue. If you have time in future, I'll still invite you, and you would always come and sum this up for us and let us understand the need for this, from especially being the head of department and sitting at that point. There's a lot that you see, and probably when I get to class and I tell the student, they'll be wondering why I say it. And now it's coming out from not just me, but the head of department as administrator, and also being the leadership position. So I guess that mostly I speak from research perspective and also as a teacher, but now she's adding that flavor in terms of administration. So that is key. And I do really thank you for making time, and look forward to that hopefully next month, to help us spread the information regarding mathematics and STEM. At this point, I know we've spent quite a bit of time due to time constraint. Let's agree that we take up to 3 to 4 comments or questions. And then after that, our Deputy Dean sums it up for us. And I think that would be it for this month, and would also use the opportunity to say we do welcome you to the next month's session, but look out for the call towards the end of next month. So let's first take 3 or 4 comments or questions, and before our Deputy Dean shares some words of wisdom with us before he leaves, or before we all leave. Any comments please, you can now mention the presenter's name, the set of presenters, and talk to them and pose your comment or your question, and they will respond. Any comment or any question, please? All right, I'm assuming that at least so far we are good. We're good either to have a discussion beyond this, or we're good because we are, well, good here. But in future, please look out for that, for the call. And our students who are here do invite other folks who are in the field of mathematics and science. And hopefully next time, actually this could be a class for my own students. If you listen to some of what our speakers are talking of, this is precisely what most of it are what we seem to be discussing in class. Listen to your head of department, Dr. Heloise, Dr. Martin, your own colleagues have almost presented some of the things we tend to speak in class. So we'll see how it goes next month. But if we have no comments or questions so far, our Deputy Dean, Dr. Mora is here. Please, if you would be kind to share some words of wisdom with us, and we'll see how it goes next month. Thank you very much, Doug.
Thank you, Prof. Bayaga. This presentation has been a wonderful experience. I'm sure that all the delegates who's partaking in this presentation over here would have found it absolutely interesting, and the range of topics, you know, that we presented on was really something that brought it all together. And we can see that, you know, the quality of our students that we have is, we have high quality students. There's no doubt about it. What I particularly like is when the students actually take their, you know, when they prepare their presentations, they actually make reference to the work and the literature and to bring it all together. The visuals were fantastic. Everything that I've seen today is saying that, you know, we in the faculty are really on a good wicket over here, and we're producing high quality teachers in the future. I've no doubt about that. What is also interesting is what you have put out over there is, you know, our students actually should come back to and take and extend some of these topics into an honors, into a master's, and perhaps a PhD as well. And I think this is a stepping stone where we can stimulate a discussion and encourage our students to say, this is, you know, getting the teaching qualification is not the end of saying we got a qualification and now we're teachers, but we can move on for an academic career as well. So I think overall, the whole experience has been absolutely wonderful today. The quality of the presentations of a high standard. And I thank Dr. Satora in the end to pull it all together in terms of speaking about, you know, the state of mathematics education and where we need, you know, teachers to go out there and to make a difference and stimulate our learners to work exceptionally hard in mathematics. And what we actually need is to encourage them to become teachers of mathematics as well. Overall, I want to say thank you so much to UNAS, Prof. Bayaga, for putting this program together, for encourage our students to come forward and make these presentations. And I cannot wait for the next series or part 2 in a month's time or whenever it's been scheduled to be part of this again. And I like the idea that, and as Prof. Bayaga, is that you're encouraging the students to come forward with the presentations. I think this gives them a time to reflect, a time to think, a time to do research, and come up with a wonderful presentation. So overall, I want to say congratulations and well done to everyone. And I thank you, Prof. Anas, again, for making this event a wonderful experience. Thank you, Prof. Bayaga.
Thank you very much, Deputy Dean. I really appreciate it. You've been instrumental also here. I would like to, even though I may not mention everyone's name here, Of course, your name comes up as having started a conversation with you right through to with my head of department and my dearest colleague, Vianney, of course, our colleagues, my colleagues, students, my colleagues / students, Amy, special thank you to you, Amy, Bulana, Nyati, Nalisa, all of you. Thank you very much for being courageous to, I know, look, I'm saying this as a master's student then. I'm being frank with you. I couldn't do this. I wouldn't even come out and do a presentation. It was only later I had to develop the skills. So if you guys have been able to do this during your undergraduate, I mean, that's great. I would love to come see you guys come back. The next time your lecturers tell you to come and do a presentation, please don't hesitate. Work with him or work with me if you can. And then we see how it goes. Pretty sure gradually you'll be able to develop the skills, spread information, tell your colleagues, tell your in-service teachers, those of you who teach in different schools, start spreading information that monthly we have STEM and maths sessions here, not only from academics, actually from you guys, and we would also love to have them, the in-service teachers, on board. I see GMMDC, Gavin Becky Center, Karen is representing them. I know you are working a lot with other folks outside of the university. We wouldn't mind to have 1 or 2 of them do a presentation. You would not listen to just your lecturers, but you also listen to folks like your head of department, the deputy dean, looking at it from administrative perspective, and the science faculty, Dr. Martin, and so many colleagues. In future, it will go beyond that. And so I'm saying again, thank you to everyone who is here and hope to see you again next month. Those of you who wish to do a presentation, you can send your names, you can let me know. We'll start working towards that towards the end of the month. Otherwise, like I say often, I salute all of you and please travel safely wherever you are. Thank you again to all of you. Bye-bye.